Hello. In this chapter, we will talk about the data structure. Do you think that data structure is just another computer science verbiage that is of any interest for you, engineer? Maybe not completely. The more the data structure is creepy, the more you waste time using it. The most dangerous kind of waste is the waste we do not recognize. Data is the fuel of data management systems. So, it is better to use the finest fuel, delivering the ultimate energy. In this chapter, you will discover how Gear Lab handles data, and how these data are used to create intelligence. This chapter presents some practical examples, taken in the car industry, because this is where the data management is one of the most critical. However, Gear Lab is not limited to the automotive industry. Wherever you are using a PLM system, the following statements are frequently true. The first example is about fasteners. A car may contain up to 5,000 fasteners, like bolts, nuts, washers, etc. Fasteners are sometimes security critical and must be precisely managed by engineers. The second example is about general figures. A car is mainly specified by some general figures like dimensions, weight, price, etc. Do you think that these data are available in the data management systems? Be ready to be surprised. The last example is about the apps. Whatever the domain of activity, each requires the highest level of accuracy to be competitive. This is where dedicated apps create intelligence by making specific controls. What about these apps? Example 1. Fastening a side mirror to the front door using 3 fasteners. Let's have a look on the data structure needed to store these data. The PLM situation is compared to IQS. You will find that, the more the data structure is complex, bouncing from one structure to the other, the more the human cost is high. The more the chance to harvest an issue is high. The more the engineer stress is high. A car project may contain up to 5,000 fasteners of this kind. The following data structure and labor is what is currently practiced within a world-class car manufacturer using PLM. Step 1. You create a first data structure to define an interface between the side mirror and the door. This involves 3 engineers and about 1 week. Step 2. You create a second data structure called connection to define the set of bolts, nuts, and washers to fasten the side mirror. This involves another engineer, a fastener specialist, and another week. Step 3. A 3D numerical definition is created to specify the fastener. This involves another engineer for 3D drawing. Step 4. The fastener supplier will supply another 3D definition, practically the same as the previous, which represents the real fastener. This involves another engineer on the supplier side. Step 5. The car architecture team creates what is called a product node data structure, which will contain the fastener data, mainly the data about which workshop in the final factory will use the fastener. This involves 2 engineers to complete the process and takes about 2 weeks. Step 6. The same team creates also what is called an expected product data structure, which contains the use case of the fasteners. Add another week. Step 7. Finally, a 3D engineer, the same as Step 3, puts the fasteners in place, precisely. So, this process needs 7 steps, involves 8 engineers and 4 weeks elapsed time, all working with the engineering PLM system. And 6 different data structures involved, each one carrying a tiny piece of information. Furthermore, the detail of this complex process is not fully mastered by acting engineers. Then, the fasteners data in PLM contain a significant number of issues. To make it right, when the engineering PLM handovers to manufacturing PLM where no issue is tolerated, then a human touch is required to make it manually into an Excel file, as usual. The result of this cleanup is never reloaded in the engineering PLM to make it right and be eventually used as a knowledge base on future projects. The issues remain unfixed forever. Well, are we talking about 1. Multiple puzzling data structures, bouncing from one to another to finally collect all useful data? Or 2. About massive waste creation? 1, 2, or both? Your choice. Nevertheless, fasteners are far from being the sole dirty data structure in PLM. Now the same example of fastening a side mirror to the door by the Gear Lab IQS. This table shows the required steps and the number of involved people at each step, with PLM compared to IQS. Only two data structure are needed. The 3D model, managed by the CAD system mainly, is important, however not exactly a data management matter. The second is the related data, like mass, cost, fastening torque, typically being managed by the IQS solution. This is the minimum required. All required data are grouped into a unique view. This is straightforward for engineers to focus, to discuss, and to acknowledge the fastener's accuracy, all together and once for all. Finally, 5 engineers are involved, this cannot be less. The side mirror engineer, the door engineer, the fastener referent, the BOM manager, the 3D engineer, the interface stage, involving 3 engineers, but, in fact, creating no value for fasteners is left out. Same for the useless connection and the supplier's definition. Thus, about fasteners in IQS, the bottom line is much faster in execution, more reliable, less issues. This is due to a much simpler data management. Less expense, less labor cost. Engineers then more confident and relaxed in their duty. Think simple, take altitude, and wipe out useless complexity. Example 2, general figures for a project. Whatever the project, a lot of general specifications and figures are just required to engineers to fulfill their duty, like the dimensions, the weight, the production cost, target countries, competitors, resources and planning. All the figures you would find previously in a handbook, which do not exist anymore, presumed to be replaced by the PLM system. You believe it? Great! What is the real situation in PLM today? About dimensions. Not a single dimension is available in the PLM data management systems. You need it? Forget PLM, ask the car architect by phone, or learn to use your CAD system. About weights. Each part in the BOM is supposed to have a weight data in PLM, but the BOM is not accurate, with missing parts or redundant parts. Lot of parts have no weight or with a non-consistent unit, kilogram, grams, or tons, all mixed. PLM is just not even aware of. Forget PLM, you'd better use Excel. About costs. The production cost is hopefully part of PLM. But, because basically the BOM is not consistent, the cost cannot be calculated accurately, trustfully. So, to obtain a reliable cost, a second specific BOM is built manually, hardly synchronized with the reference BOM. Try to use PLM at your own risk. About countries. You may find in PLM, the country where the final car is manufactured, but nowhere in PLM you will find where the car is marketed, for which specific regulations, etc. You need it? Forget PLM, ask the project director, by an email. About competitors. You will find absolutely nothing in PLM. Forget PLM, go your way. Purchase other dedicated systems to help. About resource and planning. Same, nothing at all. Forget PLM, your company may have purchased a separate ERP system. Just learn to use it out of PLM, good luck. Compared to IQS. In IQS, the BOM is the foundation of all, not an option. And it is accurately managed by the Gearboard Smart System. Whatever mass, cost, capex, etc. The BOM is everywhere. GearLab Digital takes care of the BOM. Then it is fully accurate, trustworthy. About general figures, which are not included in the BOM. Engineers need these basic figures, dimensions, regulations, countries to market, etc. GearLab is engineer dedicated. We are engineers in the first place, we know precisely what matters for engineering. Everything engineers need to fulfill their duty is centralized in IQS. GearLab is smart, starting with the Gearboard data organization. In GearLab Digital, data are not only stored for viewing, and that's all. Data consistency is checked, if not regular then highlighted to acknowledge. These data are used for self-learning mechanism and further dedicated calculation. About competitors. Is your product challenged on the open market? Automotive, insurance, food industry, etc. Knowing about your competitors is vital then. Obtaining detailed information about competitors is technically easy to process and to attach to the Gearboard data structure. However, it needs to be discussed in terms of legal matters to make it happen. We believe that a win-win situation is in sight to make it happen. About resources and planning. Human resources and planning management are the basic of QCD management. There is no magic, resource and planning are managed by GearLab as other design parameters. Find more in the next video. The architecture reference is a basic design data widely used in a vehicle project. This document summarizes the main numerical figures of a car project, like dimensions, ground clearance, some angles, etc. This reference is not in PLM but in the CAD system. PLM has no idea of these figures. Thus, for the simplest basic calculation, this is just out of sight of these systems. PLM is versatile. The real engineering job is ignored by PLM software developers. The actual need is just ignored, nobody cares about it. Engineers live blind and deaf. This is not the business of PLM. GearLab is engineering dedicated instead. Developers are actual engineers in the first place, they know the job. So, all basic data to fulfill the duty are part of the IQS system. Not only a dead pixel picture stored somewhere on a paper sheet out of PLM, but all numerical figures are known and used by IQS for precise calculations using specific apps. Third example, let's talk about apps. Your domain is automotive, aircraft, insurance, ecology, medical. Not a lot of common concerns across these domains, each having their specific basic skills and dedicated features. GearLab is in fact not versatile, but dedicated. Being versatile means doing all-purpose, then finally doing nothing, no purpose. Dedicated means that each domain is covered by specific applications, apps. GearLab solution is indeed dedicated by domain, with its dedicated apps. Example 1, for a car manufacturer a major concern is the CAFE. CAFE means corporate average fuel economy. The tire's choice may have significant effect on the fuel consumption. You want to change a tire size? This influences the road friction, CX, mass, etc. Then automatically the CAFE contribution is computed by a specific automotive app and displayed. No PLM system will give you such a calculated result, because this is a car-dedicated matter, not versatile. Yet, GearLab apps will make it so. GearLab Digital is an open framework to integrate third-party apps, even your proper private apps, for your specific domain. This is what we call engineering intelligence. Example 2, let's examine the principles of a smarter dedicated app, Build My Car. Imagine a new car project starts in your company. Then, some rough information about this new car is known immediately, like the new car project is XX7, a C-segment plug-in hybrid SUV. Meant to be a successor of the previous XX6 project, powered only by an ICE powertrain. In the portfolio of your company, you have already some other car projects, managed by IQS. WW6, a B-segment SUV. SS6, a C-segment PHEV station wagon. YY6, a D-segment SUV, marketed under another brand. You are committed to including in XX7 some innovative features, an ADAS system, and new seat comfort features. All these data being managed by IQS2. You are requested to increase the overall length by 50 mm maximum, the height and width reduced by 30 mm, compared to XX6. And as usual, the production cost, the capex, the quality, and the weight are challenged. Now let's ask IQS to imagine the car. These are a lot of very simple but useful specifications. Yet, this is enough to start creating an rational technical proposal by a skilled human engineer, to predict some general figures and create realistic targets. We are talking mostly technical, including some dimensional constraints for styling artists, to help them start the styling process, which is done out of IQS with very specific artistic software. This is a standard task to realize in pre-project phase, until the project commitment starting 9 months later. No PLM system is designed to work it out, even with some million euros spent to make it happen, unsuccessfully. Will IQS be able to make it so? Okay, let's see how GearLab Digital could process this information to generate intelligence. The first step is the gear board to create functions. It contains basic information about required functions to build a car. Whatever the segment, the powertrain or the brand, a car contains. For wheels, front and rear suspensions, a floor panel, front seats, a powertrain, a dashboard, a steering wheel, etc. We are not talking yet about physical parts, but just about some features, called functions. Then, the Build My Car app brings other car-specific additional data, in fact, some patterns. Like, PHEV powertrain, BEV powertrain, ICE powertrain, SUV pattern, C-segment pattern, etc. Excellent, select here the patterns that you need to the previous gearboard pattern of a basic car, then you have a standard generic SUV. Great! But that's not all. This is a generic SUV yet, not the one specific to your company. The brand for which this SUV is meant to belong has its own specific pattern of functions, like power seats, front camera, LED display, etc. So add these patterns to your SUV project to bring them in. Then finish your SUV function creation by adding your specific innovations like ADAS and seats comfort features. And we're done for this step. We have a typical bill of materials, BOM, for our car project, with minimum data and maximum result. Until now we are still talking about functions, not yet parts. This is the next step. Later, you will be requested for a lot of good reasons to modify this basic BOM. This is a normal job. It stays as straightforward in IQS, as simple clicks, and as cumbersome in PLM, as a long process of about 4 weeks, for the simplest request. Now consider this, obtaining this breakdown seems easy. Yet it is as easy with IQS. But without IQS, it is in the range of a skilled engineer, for sure, but takes several months to obtain. And with PLM it is just out of range. Forget it. The next step is to put your BOM in life by linking part data to each function of the gearboard built right before. We continue to think simple as usual. Whatever the part to attach to the gearboard of our SUV, it could be in one on the 3 states below. A new part to design specifically for our specific project. A part to carry over from a previous project as it is. A modified part means carryover with some changes. Now the Build My Car app will take it in charge and suggest parts in each category, smartly selected in the IQS database, by applying some rules. If a part is visible to final users, so needing styling, like structural outer panels, interior trims, lights, seat cushions, by default, they are all new. All parts non-visible to the final users, like the powertrain, the driveline, the HVAC, the seat internal structure, are by default carryover from other projects. All parts in between, so not visible to the final user, but, depending to new styled parts, are set to modified, so not carryover, but issued from, like wiring harness, bumper beams, wiper system, etc. No need to be an engineer to understand these statements. Just think simple and make it as simple. So let the IQS Build My Car app to select these parts automatically, by a mathematical logic, with available data from other projects. Waiting a couple of minutes to obtain a complete result with a complete BOM until the final parts. The associated costs estimation, total production cost, capex, labor. A typical planning, roughly estimated. Some performance evaluations like weight, range, quality quotation, etc. Skilled engineers can do it exactly same way. Just spending 9 months to build these statements, but less exhaustive, less accurate and less faith in the results, just because done by a human with his personal faiths, not always fully objective. Nevertheless, this is just a proposal, created with agility, to be acknowledged partially for some functions, and for remainings, request IQS to propose more options, or a manual tuning in some cases. We just don't waste any time. To collect several dozens of Excel files. Call relentlessly dozen of colleagues to obtain tiny information. To create tables and KPI for several hypotheses to choose the best one, all manually done. All required data is already in the IQS database. And the IQS Smart Engine is enabled to use it with mathematical rigor, fast and accurate. Then the final engineers in charge will use the smart data to decide, with all cards in hand. You are certainly able to make big decisions with less data. But it will cost you more. To summarize this chapter, GearLab is a smart solution, not a dead-end data manager. Dead-end data manager? What is it? Consider a blind numerical data stored into a database like 12. What this number is about? A length, an hour, an angle? Any idea of its consistency? Then this data can't be used for any intelligence. Just a dead number stored in the database dead end. Then with a smart data manager, thanks to the Gearboard organization, the system understands the data. It is in fact a weight in kilogram. It is a weight for a wheel. A wheel for a passenger car. The mean weight for a passenger car is 12.5 kilograms. The minimum is 8 kilograms, the maximum is 20 kilograms. So, 12 kilograms is in the range, close to the average, okay. If out of the range or close to boundaries, then IQS will warn the user to acknowledge. Then the system is smart, not blind. Being lean is not to blindly record and retrieve data using a database, but using a straightforward process with all data available as required. With data consistency being smartly checked, and with dedicated applications for dedicated domains. Staying blind and flooded in the stream of data is pure waste, but usually even not identified. Thus, the most dangerous kind of waste is the waste we do not recognize. Now, let's compare IQS to PLM. As a summary of what we learned until this chapter, by using a simple matrix, where the X horizontal axis is about wastes, or values, and the Y vertical axis is about data, or process. So, the first quadrant is waste of data, so simply storing data. When too large data is stored, dispatched on too many tables, any consistency control before recording. Therefore, there is a lot of useless or unused data. The second quadrant is about value creation, so to obtain results. This is to request the system about your need, and to obtain a response. Then to be more specific, to tune the answer until full satisfaction. Then enjoy playing this game and jump to the following request. In each step, creating new values. The next quadrant is about the process, those to recover issues in data. You know about your data being contaminated by issues. Then, you spend your engineering time extracting these data into Excel files and to manually recover issues. Back to Excel? Or back to the past? The last quadrant is about the process of new data creation. A process smart enough to create new data. However, there is no magic. New data are created by using available data in the database. This is the capitalized knowledge of your company, and using dedicated apps to deduce new data. This is about the specific know-how of your activity. In this simplified representation, the top right corner is about obtaining the maximum with the minimum, when the bottom left is about doing the maximum for nothing. The left column is about PLM. The right column is IQS. As a former engineer of a major car manufacturer using PLM systems for a decade, this is what actually happens. Engineering population just ignoring about producing waste, being unable to recognize it. The bottom line is that PLM is certainly a significant step to digitalize data management, but not the solution. The PLM is just a versatile data recorder. IQS is more about a dedicated smart engineering device, creating values. That's all about lean data management. Do you see better now? The data structure of the computer system does have real functional effects on the way you will work with. So, it is not out of your interest. Interested in finding more? Then follow on to the next chapter, where we discuss the specific machine to empower the data. The destination is in sight. We are on our way toward our destination. Goodbye.